everyone. My name is Paula Nabais. I'm a heritage scientist. I did my master's in 2014 in conservation restoration within the Mobile Laboratory, which is financed by the European infrastructure, European CH. And what it is that they take portable instruments into the museums or institutions to analyze different artworks. During my master's, what I was able to do was study the yellow dyes present in pre-Columbian codexes of the Vatican Library. I did my PhD in Nova School of Science and Technology from the Nova University of Lisbon. I kept my collaboration with the Mobile Laboratory, and I studied the red organic colorants present in Portuguese manuscripts in a methodology which is now being applied to the study of textiles, which I'll explain a little bit later. I'm currently a postdoc researcher, and I'm also preparing a project disclosing lost yellows, in which I intend to develop a methodology for the identification and characterization of faded yellows in artworks. So why manuscripts and textiles? Because all of them use dyes, and the topologies of dyes are analogous to both textiles and manuscripts. So we find the same dyes, weld, Brazil wood, indigo, and others, both in manuscripts and in textiles. I'm within an interdisciplinary team that studies these organic colorants from the Universidade Nova de Lisboa. And I also collaborate with the different faculty, the social sciences faculty of the same university within the Medieval Studies Institute. I also collaborate with different researchers from all over Portugal and institutions that have these precious artworks. I have a broader collaboration network with researchers from all over the world, specialized not only in medieval manuscripts, but also in textiles and especially organic colorants. From these, I highlight the group Dyes in History and Archaeology. Some of the members are also in this EuroEP cost action, and it gathers specialists in these dyes, from chemists to historians to artists, all of these for the study of dyes in archaeology. The world of organic colorants is very broad, and we know that more than pigments, they can be very geographical and geographical specific. So for example, lac dye and kermes that were extensively used during the Middle Ages were later on replaced gradually by the presence of cochineal and Brazil wood after the discovery of the New World. Some dyes were kept since antiquity because of their coloring hues, such as indigo, and some yellows, such as weld, but the world of yellows is way too big to be represented here. So although, even though that we have dyes present both in textiles and in manuscripts, also the form in which they're present in is very analogous. For example, in textiles, what we have is a metal that mordants the textile so that we can have our dye present. So for example, we have the dyeing matter, Brazil wood, which is mordanted to our textile using this mordant, which is usually alum. In manuscripts and in paintings, usually these dyes are present in the analogous form, in which we call lake pigments, which is also the precipitation of the coloring matter using also this mordant, which is alum. So the form is very much similar. Depending on the recipes, the same coloring matter could hue different tonalities, as we have here. All of these colors are just from different recipes of Brazil wood, as you can see. So the recipe has a great impact on the final color of the product. This is where our methodology is very different from other groups specializing in dyes, because we look at these different ways to produce these colors. We know that these ways and these recipes were very chronological and geographically specific. So we're looking really at these specificities of the recipes. And we do this by the use of historical accurate reconstructions. So to do these reconstructions of these recipes, we go to the sources. So we go to the treatises, to the recipe books that have these recipes that traveled all over Europe and all over the world. And we reproduce these recipes. If you want to understand a little bit more about our modus operandi in this way, I would advise you this article in which we've been experimenting for the last 20 years on a particular Portuguese Hebrew illuminator's manual, which is very interesting. So after we do our reconstructions, what we do is we thoroughly analyze them. So using a multi-analytical approach, and we search for what we call recipe markers like a fingerprint for every recipe of the colorants that we have studied. And then we can try and see if we can find these recipe markers on specific artworks. This can give us very, very important information on when and where a specific artwork was produced. So this was the foundation for my PhD thesis. In this case, for the recipe markers, I tested an equipment which is called fluorimetry, and it can give us very important information on the environment in which these chromophores are present in an artwork. And I used this with our database of reconstructions, and then I also tested this on data acquired from artworks. To extract more information, what I did was I used statistical methods. And I did this for four red organic colorants that we know that were extensively used, especially in medieval illuminations: Brazil wood, cochineal kermes, and LAQV. So for our first model, using our historical references, we were able to discriminate between all red organic colorants. And this is important to say because this is a method that does not require microsampling. So I can do the analysis in situ. And although we were expecting to find differences between Brazil wood and the other chromophores, it's important to say that discriminating between all of these using just an in situ method is interesting because they're all from the same family of colorants, which are the anthracanones. Then we try to see if we can get a little bit more information. So we focused on data acquired from artworks, and we focused just on LAQV and Brazil wood. And we were really happy because our method was able to differentiate between recipes of the same colorant as we have here. So we have 5 different recipes for LAC and 3 different recipe types for Brazil wood. And we were even able, for the first time, using a non-invasive technique, to find out that we have the same colorant, both colorants, LAQV and Brazil wood, present to prepare the same paint. And it's a really good match with one recipe from a manuscript called the Jean Lebec. So this is a really broader approach. Although we tested this on medieval manuscripts, now what we want to do and are starting to do is test this approach using data acquired from textiles, because we know that it can also provide a lot of information using other artworks. So just a small project to see what kind of work that I do. So we also studied medieval watercolors, and those were like little clothlets that were sold all over the world that would contain this color. And then they would extract the color using an aqueous medium, and they would paint or use it to color everything with it. So Missile blue was known to do that. Folium was another medieval color, and Orchil as well. The one that we're more interested in is Folium, because until now the structure of this was unknown. So we couldn't really say that we've identified it in different artworks because we really didn't know what the molecular structure of this color was. So it's these beautiful fruits that belong to this flower. The fruits are really, really tiny, as you can see here, are less than 1 centimeter. And we have them in Portugal. So we went and looked for them. We went to southern Portugal and collected the fruits ourselves in different years, in different stages of the same year, to see how the color would evolve in different seasons. And then using these fruits, what we did is we reproduced a medieval recipe to produce these cloths. So we squeeze the fruit into the cloth and we get this really dark green color. And then we place it over urine for several days, as you see here, and we get this beautiful, beautiful indigo blue color. And then if we put it on the sun, what we get are these purple hues. So the blue is before the sun and the purple is after exposing it to the sun. And then if you want, you can extract the color using gum water or glare, and then you can extract the color to paint with it. This was really important because what we found was that the same specific recipe was repeated throughout different recipe books. So from the 14th century until the 15th century, and then even up until the 18th century, there was an industry in France, in Gringalac, where they would the village would basically live on producing these rags to sell all over the world, especially to Germany and Holland, where they would extract the color to color wines, cheeses, and liqueurs, as we have it here. So it's really interesting how these medieval watercolors and these clothlets traveled from the 14th century up until an 18th century industry. Because of our ability to reproduce these recipes, we're able to finally disclose the unknown molecular structure for this organic colorant. And if you want, you can learn a little bit more about our extensive work on this article. So I'm in NeuroWeb. First of all, I really want to learn a little bit more about textile technology, fibers, and I want to contribute with my knowledge on organic colorants. Specifically on working group 2, I really want to explore the meaning of color throughout areas, cultures, ages, because I know that they would use color also to mainly express their social status, and this would be very important for me to understand a little bit better. I want also to contribute with the chemical analysis, also to show you that HPLC is not the only available analytical method that we can use. Others can give us so much more information, not only on the identification of the dye, but also on the specificity of the recipes, which I believe can be very useful for archaeological and historical studies. Thank you.